Hello students, welcome to Sri Jayendra's Ring Zone classes. I am your friend and mentor for coming classes with respect to physics. This is lecture number 13 of a unit motion in a straight line. So let's begin with today's class. In the previous lecture we were discussing the kinematic equations for uniformly accelerated motion. What are their relations? Which are they? Yes, it's in V is equals to U plus AT. Next is the S is equals to UT plus half AT square. Third is the V square minus of U square is equals to 2AS. And distance traveled in nth second, it's a distance traveled in nth second, it is S nth is equals to U plus A by 2 into bracket 2n minus 1. In this symbolic notifications, we have used V as a final velocity, we have used U as an initial velocity, A as an acceleration, T as a time, and S as a displacement. In previous class we already discussed that first thing, and very important, this can be used for uniformly accelerated motion. This is used if and if acceleration is constant. If not, we are not supposed to use it. First thing. And second thing, this all are the relations for the displacement, not a distance, but I can use for a distance if it is a motion without having any u-turn. If it is having a u-turn, I should not use it directly. Yes, so let's begin with today's questions. Yes, as you have previously did in the last class, that you just see the question, pause the video, try to attempt it. A same thing would be continued, a same thing should be there, that go through, have the data, pause the video, again unpause it and check the solutions. Yes, so let's begin. A question 1 of today's class, what they have given, go through this very carefully but very quickly. What they have given is a body starting from rest, okay, with uniform acceleration, okay, travels distance n1 in first t seconds and travels the distance s2 with uniform velocity in the travels with the distance s2 with uniform velocity in next 2t seconds. Okay, then, okay, so if I have a look, this is t, this would be again t, this would be again t. Yes, and they tell me that with uniform velocity in the next 2t seconds, with uniform velocity in next 2t seconds. So this is the distance s1 and travels a distance with a uniform velocity in the next 2t seconds. So this is their distance s2. Now I need to I need to relate this to I need to relate this to how could I do this? So pause the video and go for this. Once you are back, I would be here only. Yes, so now let's begin with this. What I can do is, I know that this is u equals to 0. I know that this is u is equals to 0. Even acceleration is constant. So if these two conditions are matched, and one more, it's a time interval, that time interval is same, that's time interval is same. Yes, so there would be a change in this options, one of the option or none of the option is matching, so I need to change it. But uh, let's leave it and solve this question. How could I do this? How could I do this? So what can I do is that velocity is 0, acceleration is constant, and time interval is same, and time interval is same. So this is the situation, this is t, this is t, this is t. This was the first, it was an s1 and that s2, s1, s2, s2. So if I can write like this, it's a 1, distance traveled is the 1 is to 3 is to 5 is to 7 is to 9 and onwards. Yes, so if it is x, if this is x, then that should be 3x. Yes, and this should be a 5x. This complete distance they told me as an s2. So if I write s1 as an x, my s2 should be a 3x plus 5x, it is 8x. So if I take a ratio of this, it's s2 divided by s1, this is equals to 8x is to x. So this is s2 should be is equals to 8 into s1. Yes. What was your answer? What was it? Is it same? Are you sure? Great. Let's move on. Next question. The data tells that if a particle starts from rest and moving with uniform acceleration, then find out ratio of distance traveled by body in, then find out the ratio of the distance traveled by body in 10 seconds, next 20 seconds, and from next there 30 seconds. This is your requirement, that from 0 to 10, then from that 10 to 20, and from that 20 to next 30 seconds. This is what they require. Now how can you do this? Please start doing it. How can you do it? Look at this. They have given me that u is equals to 0. One more thing, acceleration is constant, but in this case time is not same. It's a 10, it's a 20, it's a 30. But can I arrange this somehow so that time looks like same? So let's have a look. This is t is equals to 0, this is 10 seconds. Now next 20 seconds, so this is again 10 seconds, again 10 seconds. Yes. Now it is a next 30 seconds, 10, 10, again 10. Yes. Let's say this distance they called as an x3, this distance they called as an x2, and this distance they known as the x1. So if I write this, if I have a ratio of this, then what it would be? Yes. Now in my situation the distance looks like same, distance looks like same. So what I can have is, let's say this is y, then this is 3y, this should be 5y, this should be 7y, this should be 9y, this should be 11y. So my x1 is y, my x2 it is 3y plus 5y, it's an 8y, and my x3 it's an 7 plus 9, 16, 16 plus 11, this is 27y. So x1 is 2x2 is 2x3 is equals to 1 is to 8 is to 27. This is what they require. Yes. Can you do this? Are you sure? What was your answer? Is it same? Great. Let's move on and do the next question. If particle starts from rest and moving with uniform acceleration, then distance traveled by particle in first half an hour is 10 km. Then find out distance traveled by particle in next hour. This is the data. Go for it. Do it quickly. What they have given? They have given a particle starts from rest. Yes, my first condition satisfies u equals to 0. A second condition with uniform acceleration, so its an acceleration is constant. A third condition, time should be the same, but here not the case, because they said that in first half an hour it's a 10 km and you need to find out the distance traveled by particle in next hour. So time is not same by default, but what can I do is I can arrange them such as it look like the same time interval. That means if I arrange this as this is first 30 minutes half an hour, another 30 minutes, another 30 minutes, so this distance is 10. This is 10 multiplied by 3, because if it is an x, this should be 3x, and this should be 10 multiplied by 5. So because this is 5x, I hope these things are clear to you. This is x, 3x and 5x, Galileo's law of odd number. So distance traveled in next hour, distance traveled in next hour would be addition of this two. It's a 30 plus 50, that is equals to 8080 kilometer. This would be the task. Yes, yes. Now I hope these things are clear to you and you can solve this kind of questions. Are you sure? Yes, let's move to the new questions. Go through this data carefully. What they have given is, they have given that a bullet traveling horizontally loses 1 by 20th of its velocity while piercing a wooden plank. Okay, so number of such planks required to stop the bullet. How can you do this? Can you feel what they are supposed to tell you guys? Yes? No? Okay, let's have a rough sketch of it. Let's say this is one of the plank. Bullet is entering with a velocity of u, and after traveling this plank, let's say a plank having a thickness of x, when it is leaving, it is loses 1 by 20th of its initial velocity. That means the final velocity should be is equals to u minus u by 20 after traveling one plank. So this is, if I solve this, 20u minus u, this is 19u by 20. This is final velocity after traveling through a one plank. Now you want to find out that number of such planks are required to stop the bullet. So let's say this are number of planks, and this are, let us suppose n number of planks are required. Here you are traveling, here you are initiating with the u equals to 0, and you should end it up with the 0, final velocity as a 0. So you need to find out this n. Did you get my point? Are you sure? Can you do it? Will you? Yes. If not, let's have a look. What I can do is, I know that through each Planck, v square minus u square equals to 2ax. So for one Planck, if I am traveling through one Planck, my final velocity would be 19u by 20. So this is 19u by 20 whole square minus of u square, that should be is equals to 2 into a into x. On 19 square it is a 361 u square, divide by 20 it is a 400, minus of u square, that should be is equals to 2ax. This is 361 minus 400, so this is minus of 39 u square, divide by 400, should be is equals to 2 into a into x. This is the case when it has been passed through one Planck. Yes. Now I want that my final velocity should be 0 when it has been started with the u equals to 0. So the situation should be v square minus of u square should be is equals to n multiplied by 2x, because it is going to travel n into x distance. So that should be 0 minus of u square, this is equals to n multiplied by, I am having a value of 2x, which is in my case this is minus of 39 u square divided by 400. So if I replace this, it's a minus of 39 u square divided by 400. If I replace this, what I can have is this minus minus gone, this u square and u square would be a cut it out, and the n should be is equals to 400 divided by 39. This is 400 divided by 39. This is somehow approximately 11. So 11 such Plancks are required to stop the bullet. 11 such Plancks are required to stop the bullet. Get it? Yes? Are you sure? So can you do this kind of question? Will you able to solve this? Are you sure? Yes. Let's have a look. There is one for you guys. What the data has given. I can just provide you the hint, but not the complete solution of this. You need to do this. But before you start doing it, just go through the data, what they have given. What they tells us that a bullet traveling horizontally loses 1 by 10th, 1/10 of its velocity while piercing a wooden plank. Okay, number of such planks are required to stop the bullet. Only the data has been changed, and the rest of the things are the same. But let me help you guys with hints. That means they want us to do this kind of thing. It's a one of the plank, and this bullet is entering with you, and bullet is living such as its 1/10 of its velocity should be loose. This is u minus u by 10, and if I perform this, it would be a 9u by 10. What they want is that number of such planks are required to stop the bullet. That means, let's say this is first, this would be the second, this would be the third, and so on. So this, as such as this n number of planks are required, and in this case a thing should, that here bullet should start from u, and bullet should ended up with final velocity which is a 0. If this is the situation, you need to find out the n. Now you know what to do. Yes, for first situation, write down the v square minus u square equals to 2x, put a value of v and u and solve it for 2ax. Then again put the same relations, v square minus u square, v square minus of u square, that should be is equals to n into 2x, and rest of the thing, you might do it. Yes, are you sure? Okay, so do it by yourself. And let's we are going to move quickly to the next question. Very interesting. Let's have a look. What they have given is what they have given is they said a car starts from rest, okay, and travels with uniform acceleration. Their acceleration is constant. Great. Alpha for some time, and then with uniform retardation b and comes to rest. Okay, then it again comes to rest. If the total time of travel of the car is t, if the total time taken by the car is t, then you need to find out the maximum velocity attained by car. Yes. How can you do this? Can you pause this video and try doing it by yourself? Do not lose the hope. It may require 3 or 4 attempts, but it is absolutely okay if we can do it. So please do it. On the next end, I will be there to solve this question for you people. Yes, so please pause it and do it. Okay, let's begin with this. Let's begin with this. What they have provided is a car starts from rest and travels with uniform acceleration alpha for some time. So let me do one thing. Let us plot the graph of this situation. Let us plot it. So if I plot this graph for velocity versus time, what does it tells? It tells a car starts from rest, travels with uniform acceleration alpha for some time. So situation would look something like this. This is alpha. As you can see, it's a velocity versus time graph. A graph is a straight line. A graph is a straight line. That means it says slope is constant, and slope of the velocity versus time graph, it's acceleration. Yes, so this is alpha. And then it tells that it achieves a maximum velocity, so this might be the Vm that we call as a maximum velocity. And then with uniform retardation beta, it comes to rest. So it comes to rest again. This is retardation beta. Again, it's velocity. That means, I mean, final velocity would be a 0. If the total time travel of the car is t, let's say first this time is t1 and this time is t2. They are talking about this total journey which takes t amount of time. You need to find out the maximum velocity attained by this. So how can you do it? How can you do it? So let's divide our journey into two segments. Let's divide it in two segments. This is my first segment and this would be my second segment. So in my first segment, my initial velocity is 0. My final velocity would be equals to Vm. My acceleration is alpha and my time taken is t1. Yes, I hope these things are clear to you. I am just observing this situation. In the second situation, in the second motion, my initial velocity, because I am going to observe this situation from this to this, my initial velocity would be a Vm. My final velocity, it comes to rest, that means it will be n 0. My acceleration, technically it is in retardation, so it is a minus of beta, and the time taken to do this, it's a t2. I hope these things are clear to you. Now let's just derive this. Let's derive this. So if I'm talking about the first situation, I can write it as in v is equals to u plus at. My u would be a 0, a would be an alpha, and time would be a t1, and final velocity would be a vm. So this t1 should be is equals to vm divided by alpha 1. This is a first relation. Now my second situation again I am going to write the same thing. V is equals to u plus at. This is the master formula. Final velocity would be a 0, initial would be an vm, and as it is a retardation, so it should be written as minus of beta into t2. So if I solve this, that t2 should be is equals to vm divided by beta. This is the second relation. Yes. Now now what I can write is that t should be is equals to t1 plus t2, because they have not provided the t1 or t2. They have simply provided the t as well. So what I can write is t is equals to t1 plus t2. Now my t1 should be is equals to vm by alpha 1, and my t2 it would be an vm by alpha 2. This is equals to t. So that should be vm into bracket, this is 1 by alpha 1 plus this is beta plus 1 by beta. So this is equals to vm into bracket alpha plus beta divided by alpha beta, and this is equals to t. So this vm should look like alpha into beta divided by alpha plus beta multiplied by time t. This would be the final answer. Yes. Yes. So go through the data, because I want you people to remember these conditions, that a car should start from rest, it should travel with a uniform acceleration for some time, and then it should retard and come to rest, and you should be having total time of the journey. Then you can find out the vmax. Now let's try to remember this. Suppose you are having an v is equals to u plus at. I'm talking about the complete journey, and you are having an u equals to 0, then this v is equals to a into t. Now in this situation, for remembering purpose only, you are going to write an alpha, you are going to write an acceleration in a different way. What is it? That different way is alpha into beta divided by alpha plus beta into t. This is my vmax, because this is one of the favorite questions of the faculties who are arranging the papers. So this is vmax, that would be equals to alpha into beta divided by alpha plus beta into t. Yes, can you do this? Okay, and shall I add something to this? Shall I add something to this? Yes, let me do it. Suppose in this situation, question number 2, if they ask me that find out distance traveled by car in time t. So what can I do this? And what can I do for this? I can have this kind of relation, x is equals to ut plus half at square, as I have begin with the 0. This is equals to half into a into t square. Now I am going to write this a differently. Now what that differently means, it is an alpha beta upon alpha plus beta. So that should be is equals to 1 by 2 into bracket alpha into beta divided by alpha plus beta multiplied by t square. This is the total distance traveled in this journey. In this journey, I mean, you should start it from rest, moving with uniform acceleration, achieves a maximum velocity, and then start retarding. And as soon as you are going to retard, it, you must come to a rest, and the time should be given for a complete journey. Then this would be the situation. Shall I add one more thing to this? May I? Okay, let's look at this. If they have been asked, this is the third question in the same segment. If they have been asked that find out average speed in the previous question, You need to find out the average speed. How can you do it? First tell me what is the formula of average speed. Yes, an average speed could be written as total distance traveled divided by total time taken. It's a total distance traveled divided by total time taken. Now what is total distance travel? It is half into a into t square, as we discussed in previous slide, divide by total time taken, it is t. This t2 would be a cancel, and the term that remains, it's a half multiplied by a multiplied by t. Now I am going to write this a differently. So this average speed would be is equals to half into alpha beta divide by alpha plus beta multiplied by t. This would be the final answer. This is my average speed. Yes. So can you do this kind of stuff? Will you be able to do this? Are you sure? Are you sure? Can you do this? Will you? Okay. So let's move to the next question. Let's move to the next question. Suppose they have given that a car is moving with a speed of 30 meter per second, comes to rest by applying some braking force. Comes to rest by applying some braking force after traveling distance x. If same car is moving with speed 60 meter per second and applied same braking force, then what will be its stopping distance? Stopping distance, that means a distance traveled by an object before coming to rest. Go through the data and think how can you do this. Go through it very carefully. What all they have provided. Yes, they have provided me a car is moving with a speed of 30 meter per second. That means u1 is given, that is 30. Comes to rest, that means my final velocity should be 0, by applying some braking force after traveling a distance of x. So that distance is, let's say, x1 is equals to x only. And if same car is moving with a speed of 60 meter per second, that means u2 is given, that is a 60 meter per second, is moving with speed 60 meter per second and applied same braking force, that means acceleration, I mean retardation is same, then what will be its stopping distance? So it is a distance when car comes to rest, so v2 would be a 0, and I need to find out the x2. I hope you understand this situation. So now start doing your work. Please do it fast. Do it fast. Can you do it? Can you do this? Will you? Yes. So pause the video, start doing it, and if it cannot be done, I'm there to solve this. So what the data is given is u1 is equals to 30, v1 would be equals to 0, and x1 is equals to x. Next, u2 would be a 60, v2 would be a 0, and this x2 is to be find out. So what can I do is that I am having an velocity, initial velocity, final velocity, and distance, as well as I know that my retardation is the same. So what you can consider is that if I write the master formula, it is a v square minus of u square should be is equals to 2ax. So this final velocity would be a 0 minus of u square, it's a 30 100, that means square of the 30, it is 900, multiplied by 2 multiplied by a multiplied by x1. So if I try to find out the acceleration, it would be minus of 900 divide by 2 into x1. Now let's do this. So again write it down, the master formula, it's a v square minus of u square is equals to 2 into a into x. Now in this situation, this is 0, this is 60 square, that means it would be an 3600. This is equals to 2 multiplied by acceleration, it's a minus of 900 divided by 2 into x1 multiplied by this is x2. Yes, so this minus minus would be a gone, this is 3600, and if I take this as in combinedly, this is 800, 2 into 900, this is, so this would be a 2. So if I write this x2 should be is equals to 4x1. Yes, stopping distance would be 4 times the initial one in second case. You can do this, did you do the same thing? Have you done the same thing? Are you sure? But let me show you a more faster and relatively easier approach of this. So what you can do is, what you can have it as an alternative approach. Let me write this again. This is u1 is equals to 30, v1 would be equals to 0, acceleration, that means retardation, is the a, or and the distance is x. In second case, velocity would be a 30, sorry, velocity, initial velocity would be a 0, 60, final velocity would be a 0, retardation same, it's an a, and the distance travel, that is what I require. Now I know that my master formula could be v square minus of u square should be is equals to 2 into a into x. Now what I can write is, let me take a ratio of this two directly, that means 0 square minus of 30 square should be is equals to 2 into a into x1. This is relation number 1. Now I'm going to write this relation in a ratio of this, it's a 0 square minus of 60 square should be is equals to 2 into a into x2. I can write like this because my acceleration, my braking force are the same. So if I am able to write this, what I can have is this 0 0 would be gone, minus minus plus, this 2a would be gone, this 2a would be gone. Now look at this, this is the beauty of this question, because acceleration is the same. What we were done previously was, first I have find it out the acceleration and then I put up in this relation, but I do not require to find out the acceleration. So that amount of time to find out the value of an acceleration and put into the different relations can be saved. This time can be saved, and if this time can be saved, this can help. So this is 30 square, it's a 900. 60 square, it is a 3600. This is equals to x1, this is equals to x2. So this is x2 should be is equals to 4 times of x1. That's it. Yes, this is alternate approach. If you have done this, there is nothing wrong in this. There is nothing wrong in this. You are absolutely correct. But as a medical student or as an J aspirants, we must know how to save my time so that that remaining time can be helpful, can be useful to do a more number of numericals. So please always use ratio. Ratio is a very powerful tool, a very powerful tool. If we can use it in a correct manner, that can save a maximum amount of time. I hope these things are clear to you, and you will practice these kind of questions by having a ratio of it. Yes. So shall I slightly modify this question and again reattempt it? Shall we? Yes, let's look. If they have given that in previous question, in second situation, if braking force is half of the previous one, find out stopping distance x2. This is what they require. You need to find out the stopping distance of the same situation, but what they did is that the braking force is half of the initial. So now the situation seems like my initial velocity u1 was 30, final velocity in this situation is 0, my braking force, let's say a, and my stopping distance were x. Now in the second situation, my initial velocity was a 0, my was a 60, final velocity of this would be a 0. Now my braking force is half of the initial, so it would be an a by 2, and I require an x2. So what can I do? Yes, taking a ratio, v square minus u square equals to 2ax. This is the master formula. So this should be a 0 minus of 30 square should be is equals to 2 into a multiplied by x1. Have a ratio of this, it's a 0 minus of 60 square should be is equals to 2 into, now it is an a by 2, it is an a by 2 multiplied by x2. So if I solve this, then the thing should look like minus minus plus. This is 30, so this is 900, this is 60, so it's a 3600. So this is 1 by 4 should be is equals to this 2a, and this 2a would be gone. So this is 2x1 divided by x2. So what I require an x2. This x2 should be is equals to 8x1. Easy? Yes, indeed it is very easy. So I hope this kind of things can be done by you guys. Please do this kind of questions. We are signing out here, but these are not the limited amount of questions for equations. There are many more questions, there are many more patterns, but our basic concepts remains the same. First thing what I need to check is that whether my acceleration is constant or not. If it is constant, you can go for this. If it is not, don't go for it. Next, what I need to find it out that my distance is there or displacement is there. If they have asked the distance, then go for it. But before checking that whether my particle is having a U-turn or not, if it is not having a U-turn, blindly go for it and use this relation. If it is having a U-turn, please be careful while calculating the distances. So please try so many questions. Even we are going to cover some more questions of previously asked questions in competitive examinations in the last session when we end this chapter. So let's sign it out. But before I go, I one more time request to you people that please practice as many questions as possible. This will save us and reach us to our final goal. Yes, thank you. Bye bye. Have a good day.